the excellent education channel. In this channel, you will be getting a lots of lectures related to the mathematics. In today's lectures, I teach you the sum of n geometric terms. In my previous lectures, I have already completed 4 exercises of geometric progressions, and here is the next exercise. Okay, and in today's lectures, I'll teach you how to generate, how to develop the formula for finding the sum of n geometric terms. Okay, students, now let's get started. Now here our topic is sum of n geometric terms. Okay, now first let us suppose that, now see, let ar square, ar cube, dot 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 dot. Let's say b. These are in GP. Okay, let us suppose these terms are in GP, and we know these are in GP. Okay, now let us suppose the sum of n terms be Sn. Okay, we suppose the sum of n terms be Sn. And here, now you are seeing here, this is the last term is b. Okay, and here are how many terms are here? Of course, here are n terms. How many terms? N terms. As we are going to find the sum of n geometric terms, that means, of course, there is the last term. Actually, there are n number of terms are there. Okay, students. Now let us suppose, now see, Sn. As we suppose the sum by Sn. So let us add them. Sum means what? Let us add. This is a. This is ar plus ar square plus ar cube plus dot 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 last terms. Now see, we know the last term is b. Okay, the last term is b. And what is the terms just before the last term? Just before the last term is b by r. And what is the terms just before b by r? Of course, it is b by r square and so on. As I have already told you in my previous lecture, in geometric progression, if you multiply the every terms, you will get the successive terms. And if you divide the final terms, then you will get the preceding terms. Okay, this is the geometric progression. Okay, now see, this is, let us suppose this is the equation 1. Okay, here, now you see, let us multiply the equation 1 by r. Okay, students, now I am going to multiply these all terms by r. If you multiply Sn by r, it becomes r into Sn equals to, if you multiply a by r, it becomes ar. If you multiply ar by r, it becomes ar square. If you multiply ar square by r, it becomes ar cube, and dot 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 dot. Now see students here. Now plus, if you multiply b by r square into r, it comes b by r. If you multiply b by r into r, it comes only b, and the final term is b into r. Okay, let us suppose this is the equation 2. Okay, students. Now let us subtract these two equations. Okay, now let me subtract these two equations, students. Now see, this is minus, minus, all. Let me subtract it. Now see, this is subtraction. Now what would you get when you subtract here? Now see, this, all these terms are being cancelled here. See, this is second term, first term cancel, third term, second term cancel, fourth term, third term, all they get cancelled. Every terms now. Now see these terms, and here is the same b by r square is term here, so they are cancelled. This also cancel. Now students see, this b will also cancel. Now from these cancellations, what would you get? Now you really get is, now see, this is Sn minus, this is r into Sn equals to, now see what left here? Here is a is left, and you see here there is only minus br. What is minus br left? Okay, students. Now let us take Sn is common. It left is 1 minus r. Now see, Sn is common. 1 minus r equals to a minus br. Therefore, Sn equals to a minus br by 1 minus r. This is your one formula. Yeah, this is the formula for finding the sum of n geometric terms when this is last term is given. What is last term? This is last term is given. Now say, here we have b is the last term. If you are given the last term, then you can directly use Sn equals to e minus br whole divided by 1 minus r. Okay, students. Now let's derive the next formula. Now say from here, as we know b is the last term, What is the formula for last term? And last term we generally denote by what? Tn. Yeah, last term is denoted by Tn. So Tn equals to what is formula? A r power n minus 1. Okay, students. Now the last term is a r power n minus 1. So from here now see, let us substitute. Let us substitute the value of b, a r power n minus 1 here. Now what would you get here? As n equals to a is a minus what is b? B equals to a r power n minus 1 into the r is left here. Okay, students, the r is left here, whole divided by 1 minus r. Or you get here as n equals to, now a is common, students, a is common here. What left here? 1 minus r power n minus 1 into r. Yes, students, here into r. Can I write this into r here plus 1? See, students, now see, it is the indexing rule. Now if there is r power n minus 1 into r, what can you write? R power n minus 1 plus 1 indices product. This is the product rule. Okay, students, now whole divided by 1 minus r. Now therefore as n equals to, now see, this one is cancelled. Your form is 1 minus r power n by 1 minus r. This is the formula for finding the sum of n geometric terms. Okay, students, now let me just write here. Now see, students, now two formula I derived. One is Sn equals to a minus br by r minus 1. This is when the last term is given. And another is Sn equals to, this is a bracket 1 minus r power n whole divided by 1 minus r. Now see, these two are the formula for finding the sum of n geometric terms. Okay, students, now here usually we use this formula when r is less than 1. When r is what? Less than 1. But you can use at any time. But when, now see, you can, I just explained in the one formula also. Now here is what? If you take minus common from up, if you take minus common, it becomes what? Minus a r power n minus 1, and down also if we take minus common, it becomes r minus 1, and minus minus cancel. You can use this formula when r is greater than 1. Okay, students, so this is how the formula for finding the sum of n geometric terms. Okay, students, remember this formula is very important. In my next lecture I will teach you how to use this formula for finding the numerical problems. Okay, students, hope you have understood this lecture. Thank you for watching. See you in the next video. Till then, have a good time. Bye bye.